Hello, this is Mr. Waters, and this will be the last one in our morning series on arithmetic sequences and series. I think I'll be able to squeeze everything into this video, but this is about arithmetic series. Now remember, a series is a sequence where we've taken the members of the arithmetic sequence, or the sequence, and we're adding them together, and all the way up to some final number, let's call it a sub n, which is the nth term in the sequence. Right? We keep adding them up, and that comes up to be some value potentially. Okay, if we're adding a finite number of terms, and we wrote our series notation could be written, or our series could be written like this. Or it could be written like this in, hang on a second, I gotta plug my computer in here. There we go, okay. It could be written like this in our expanded form, where we go, oops, put a little plus there, 1, 3, 5, 7, 9 plus ... all the way up to whatever the final term is. And if this is a big number, then we don't have to write out all the terms. We can put plus and then ... and to the end, like this. Or we could write it more compactly in what we called sigma notation, where this was 1, where this s, sigma, meant sum or add together. From the first term up to the nth term of the series, and then a sub n was the formula that generated the series. Okay? Was the formula that generated the series. So, let's write, as a warm-up, think back to series. Why don't you take this sequence here, the one, or rather this series right here, and write 1, 3, 5, 7, ... up to the 27th term. Write that series in sigma notation, where n here is 27. So hopefully if you put the video on pause, and pause the video and you're working on it right now. If you're hearing me say this, you haven't done it, so you should put the video on pause. Okay, well, you're back. Okay, well, this wants to be however far in the series that we went, right? And then this is the series formula, right? Which is the same formula that the sequence would have. So we have to generate here an equation, a formula a sub n for this. Well, this was like we had for the earlier one. A sub n is equal to a sub 1 plus n minus 1 times d, right? A sub 1 is 1. D evidently is 2, right? So it's going to be n minus 1 times 2. So that's 1 plus 2n minus 2. So that's 2n plus 1. So that's a sub n here. And then I said up to the 27th term. So in sigma notation, we're going to write it like this. 1 to 27, 2n plus 1. Okay? So that's the sigma notation. So we'll call that example 1. Now, I'll give you one in case you're going, oh, I didn't know how to do that, but now I do. Okay, so let's try it. Let's do it again here. Example 2. How about this sequence? Negative 3, negative 7, negative 11, negative 15, negative 19, negative 23. Oopsie, and those are obviously supposed to be pluses because I want this to be a series, not commas. So that's negative 3 plus negative 7 plus negative 11 plus negative 15 plus negative 19 plus negative 23. Write that series in sigma notation. Okay, and you're doing that right now. Hopefully you're not just sitting here looking at your screen. You've put it on pause and you're busily working away. Because that's what you're supposed to do. Okay, so you're back. Or maybe you're waiting because you weren't sure what to do. So example 2. Okay, so again, we want to know, we're going to write the sigma here, just like that. And we're going to go from 1 up to n. N is the number of terms in the series. So 1, 2, 3, 4, 5, 6. There's 6 terms in the series from 1 up to 6. And now we need to know the series formula. Well, we can see here, hopefully you can see it's supposed to be subtracting 4 every time, starting at negative 3, going down to negative 23. And then I think you're going to see that we're subtracting 4 each time, assuming my arithmetic was correct, right? So D is going to be equal to negative 4. A sub 1 is equal to negative 3, right? So A sub 1, or A sub n, is negative 3 plus n minus 1 times negative 4. It's negative 3 plus negative 4n plus 4, right? Negative times negative is positive. So we add those. That's negative 4n plus 1 after we finish combining like terms. So that generates the nth term in the sequence or in the series, either way, okay? Because the series is just the sequence terms added together. So I'm just going to put negative 4n plus 1 over there. And there is our arithmetic series written in sigma notation. Okay, very good. So we're going to have a couple of those on our classwork and on our homework, right? And put that over there. Now we want to do, here's a classic now you notice, by the way, bringing back here, last time, besides writing the series in sigma form, what we also did was we were able to evaluate them. That is, we added these up and actually got a number that all of these would add up to, right? So what would, like this one here, if we added up that plus that plus that plus all those up, what would be the sum of the series, okay? And this one here, if we actually did add up all the way up to the 27th term, what would that add up to? Well, we could do it. We could get our calculators out and we could add them together if we wanted to, but it turns out that there's an easier way to do that. Okay, it turns out we've got a couple of formulas that we can use to find the sum of an arithmetic series. And I am not, at this point, going to develop this formula. Maybe if we have time in a later video, or you can search it, or it's in your book too, on page 620 and 621, it tells you where this formula comes from. But it turns out that here is the formula S for the sum of an arithmetic series. And it goes like this. S sub n is the sum of the first n terms. And that's going to be equal to n divided by 2. N being the number of terms that you're adding up, times a sub 1 plus a sub n. That's the first term in this series. That's the last term in this series. Now, there's another version of it. It's actually 2 versions of the formula. And either they're interchangeable, depending on where you're starting. N divided by 2. 2 times a sub 1 plus n minus 1 times d. Okay? And either formula can be used. This is a simpler looking formula, but you have to know not only the number of terms that you're adding up, but the first term and the last term. This formula, a little more complicated looking, you don't need to know the last term. You just need to know the first term plus what D is. So you just need maybe the first couple of terms in the series, and then this formula here will give you what the the sum of the series. Okay? So let's say that we want to. Okay, so here is example 1, and here's one common problem. Okay, find the sum of the numbers from 1 to 100. Right? So this says add up all the numbers from 1 to 100. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and so on, all the way up to 100. It's a pain. You can do it. Here's an easier way to think about it, because you want to think of this problem as an arithmetic series. 1 plus 2 plus 3 plus 4 plus ... plus 99 plus 100, right? So you can see that this problem actually refers to, we can express our problem to where those numbers are an arithmetic series, where a sub 1 is equal to 1, and D, as you can see, the common difference is equal to 1, and N is equal to 100, because we're adding up the first 100 terms in the series, we're adding up the first 100 numbers, and so there would be 100 numbers in the series, right? So now we'll use the first formula, because we've got the first term and the last term plus the number that we want to add up. So we're going to call this S sub 100 is equal to 100 over 2 times 1 plus 100. Okay, that's 50 times 101 is 50/50. Okay, so the first 100 numbers, all the numbers from 1 up to 100, were you to add them, would add up to 5,050. Okay, so that's kind of how that goes. All right. Now on the other hand, so if we wanted to, example 2, if we wanted to add, let's see, add the numbers from 10 up to 20. Okay, the sum of numbers from 10 to 20, right? Well, let me see. So the first term is 10, the last term is 100. So you understand it's 10 plus 11 plus 12 plus 13 plus 14. So we just have to figure out how many numbers that is. Let me see here. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, that's actually 11 numbers. Okay, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So that's actually 11. So N is, we're adding 11 numbers. Okay. And so it's going to be, so S sub 11, because there's 11 numbers, is going to be 11 divided by 2 times 10 plus 20, right? Let's see how that goes. Okay, so that's 30. That's 330 divided by 2. Equal to 165. All right? Right. So that's how that goes. On the other hand, what if you wanted to, what if they gave you a problem? So that's example 2. What if we had something like this? Okay. Find the sum of the first 30 terms of the series 2 plus 5 plus 8 plus 11 plus 14 plus ... up to whatever the, whatever that 30th term was, which we don't know, right? Well, notice that they give us the first term, and they give us some terms in the series, but they don't tell us what the last one is. Now, we could go ahead and, we're adding 3 each time, and we could go ahead and just figure out what the 30th term was, but it's easier to use the second version of our formula. S of n is equal to n divided by 2. 2 times a sub 1 plus n minus 1 times d, right? So a sub 1 is equal to 2, and you can see here that d, the common difference, is 3, right? Because each of the numbers have got 3 between them. We're adding 3 each time. So let's make sure that, okay, so we're going to plunk this in. So this is going to be, and we want 30 terms, so n is equal to 30, right? So that's going to be 30 divided by 2, 2 times 2 plus 30 minus 1 times 3. And I would just work that all out. That's 15. That's 4. That's 29 times 3, which is 87, right? 4 plus 87, that's 15, right? Times 15. 1,365, right? So all we need, that's that. So that was example 3. So we're going to have some where you're doing that, where you're working out, where you're just given the first term in the series and you're given d. So we'll use version 2 of our formulas if we're doing that. Now here's another problem. Another version of this, find the sum. They might give you the series in sigma notation like this, okay? N is equal to 1 up to 20. And a lot of times I don't bother with the n equal to because that's kind of understood. So I'm just going to put 1 here. That means the n number is 1 up to 20 of, and it says here negative 2n plus 21, right? And we're supposed to find the sum of this series. So here's a series again, but it's written in sigma notation. Well, again, we need to know the first term. If we want to use our first formula, we need to know the first term. We need to know the last term, right? Would be a way to do it. Well, the first term is a sub 1. In this case, since we want, this says we're going to add up the first term up to the 20th term in the series. So we want really a sub 20 there. And we're going to use this formula here. The first 20 terms in a series, n divided by 2 of a1 plus an, right? Well, a1, if we put 1 in there, negative 2, so a1 would be negative 2 times 1 plus 21, that's negative 2 plus 21, that's 19. Okay, and a sub 20, right, is equal to negative 2 times 20 plus 21. So that's negative 40 plus 21. Why, that's negative 19 as it turns out, right? So we're adding up the first 20 terms. This is 20 over 2 times 19 plus negative 19. And that's 10. 19 plus negative 19 is 0. That's equal to 0. Oh. How does the sum work out to be 0? Well, as you can see, we're starting at positive 19. And we're counting down to negative 19. And if we wrote them out, you would see that each positive number in the first part of the series has a corresponding negative number in the second part of the series. So they actually add together and cancel each other out. So in this case, they add to give us 0. Okay, so that's how that goes. We could also have used, by the way, this formula here, from here, because we can see that the first term in the sequence is, or the first term in the series is 19, and this negative 2 here actually represents the common difference. As you can see, we're counting down by 2 every time, so we could use this equation here with n is equal to 20, a sub 1 19, and d equal to negative 2, and we would still would have gotten 0. Okay? All right, very good. So that's it. So that's that's enough video for today. I'm going to put some classwork up in a little while. See you later.